Okay, gang, let's try this one. So the first thing you want to do is look at what the domain is. So for this one, you can't divide by 4. So x here cannot be 4. I'm just looking here for a second. 12 is 3 and 4, 2 and 6, 1 and 12. Okay, won't make that. Alright, so when you plug in 4, you get a number over 0, which means this is going to be a vertical asymptote. Okay, this also has, because it is exactly 1 degree higher in the numerator, this also has what we call a slant asymptote. You learned that in pre-calc. I write that as S sub A. Alright, so let's work on that first. You guys learned that in pre-calc. So the slant asymptote is the quotient when you divide the dividend divided by the divisor. And since this is linear, you can use synthetic division. So again, it's going to end up being the quotient when you do long or synthetic division. Remember, synthetic division only works for linear divisors. I'm going to do synthetic division because it's nice and quick. So 1, negative 6, 12. This is a 4. Make sure you put the divisor out correctly. You're supposed to set it equal to 0 and then solve for x. So x is 4. That's why I'm writing 4. Alright, so that's a 1, multiply, that's a 4, add, multiply, add. Alright, so this in the box is the remainder. This is the constant. This is the linear term, the coefficient of the x term. So the divisor here is x minus 2. So that is actually going to be the slant asymptote. Okay, so the slant asymptote is y equals to x minus 2. All right. Let's start working on the other stuff. So let's work on the first derivative now. Just remember, this one has a restriction at 4. So, before I do that, let's go grab the critical numbers. Let's see, does this guy factor at all? 2 and 6 would make 8, so it does. Okay. I'm just going to have to move it down a little bit here. I didn't leave myself enough room. Alright, so this factors into 2 times 6 negative over x minus 4 squared. Alright, so that means that our critical numbers here, we're going to get that x is 2 and 6. And we cannot use 4 from the denominator because that's already been claimed as a domain restriction. So you don't want to put 4 here. Alright, so we have 2. This is a critical number. We have 4. That's a domain restriction. And we have 6. That is that is a critical number. Now, let me just put an X here because you can't draw any conclusion where there's no graph. A domain restriction means there's no X value there. Alright, so let me just do that so I don't forget. Otherwise my brain sometimes forgets. Feel free to do that on your test so you don't forget either. Because these problems take you so long, it's not uncommon to forget. Alright, let's grab some test points. So how about like 0, 3, 5, and 7. All right, let's plug them into the first derivative. Now I'm going to plug it into the factored form. You could technically plug it into anywhere. You could plug it into here or here. This is just faster and easier for my brain. And again, before I plug it in, I tend to take note if anything is consistently positive or negative. So like this denominator, since it's squared, it will always be positive no matter if you put a positive or negative into it because you're squaring it. These other two can change sign. They can be positive or negative. All right, so I'm going to start and I'll put a 0 in here. A 0 in here is -2. A 0 in here is -6. So if I plug in 0, I'm getting a negative times a negative. And we already said that the bottom is always positive. So a double negative makes a positive. I have a positive over a positive, which is positive. Okay, so the first derivative is increasing. This part of the graph is going up. All right, now I'm going to plug a 3 into the derivative. 3 minus 2 is +1, so that's positive. 3 minus 6 is -3, so that's negative. So that's a positive times a negative over a positive. So that's a negative over a positive, so that's negative. All right, we're off to 5. 5 into here is positive. 5 into here is negative. The denominator is always positive. So that's a negative over a positive, which is negative. All right, so this is negative. This is going down. All right, now we're off to the 7. 7 makes this positive, makes this positive. This one's always positive. Okay, so we did our investigation there. Let's write what results we found. All right, so this function is increasing from -infinity to 2. To infinity. Function is decreasing from 2 to 4 and 4 to 5. Sorry, 4 to 6. Again, you don't want to say 2 to 6 because there is no graph right here is 4. It's not everything in between here because it can't use 4. 4 doesn't exist. 4 is a domain restriction, so you have to chop that up. You have to. All right, now we're going to go in and see if we have any maximum and minimums. That's the first derivative test. Okay, first derivative test, remember that means you have to look at the behavior around the critical number. So, for the very first one, here's the critical number. We go up on the left side of it, positive, and then the graph goes down on the right side of it. That makes this a relative max because it goes up and then down. Now remember, you have to get the xy value. You don't want to plug this back in the derivative. The derivative of the critical number is 0. We already know what that is. We actually want the height on the graph. So you have to plug it into the original. Okay, this is the original. So I'm going to plug 2 into here. So when you see me writing over here, that's me plugging 2 into that. So it's going to be 2 squared minus 6 times 2 plus 12 all over 2 minus 4. Alright, so this is what I plugged 2 into, the original. Alright, let's fiddle with this. Okay, so you're going to get 4 over negative 2, which is going to be negative 2. Alright, so our relative max, the height on the graph of the relative max is 2, negative 2. Alright, let's do the other one. And then I realized we have to write down the other asymptote that we have. Alright, so at 6, to the left of 6, the graph is coming down, then it hits the critical number, and then it goes up. So this is a minimum. We have a minimum at an x value of 6. And again, I need the xy value. The xy value. If we plug this in the derivative equals to 0. I actually want the point on the graph. So again, I'm going to plug it into the original function. Let me just make sure my brain got that in one piece. Okay. Okay, great. All right, so that's our max and min. If you're making the observation that y is the maximum a lower value than the minimum, that is actually possible because these are relatively speaking. Like this is in this area, in a particular area of the graph, this is the highest point, and in a particular area of the graph, this is the lowest point. You'll see when we draw it. That's absolutely possible. That's not an error. Alright, so I did mention this a moment ago. Let me just come back because when I was making the observation about the domain, I should have said, because remember, when you have a number over 0, which is what's happening here, I did say it out loud, but we actually have to make note of it. We have a vertical asymptote at 4. That's why there's the domain restriction. So we need to note that. If you recall from pre-calc, that would be an odd vertical asymptote because this binomial is to the first degree, and an odd vertical asymptote means that the function is going in opposite directions around the vertical asymptote, meaning one of them is heading north and the other one is heading south. All right, let's move on to the second derivative now. And oh, this video is going to cut me off, so why don't I choose when it cuts? The camera can't hold more than like 15 minutes. Okay, I will come back on I'll come back in the next video. Catch you. Bye.